Stephen Hawking is the world's most famous scientist. He's on a quest to answer the biggest question of all. How did everything in the universe come to exist? If we find the answer to that, we would know the mind of God. Hawking's goal is to discover a blueprint for the universe, but he is locked in a battle with a disease that has left him paralyzed, and it's getting worse. Can he unlock the secret of creation before his time runs out? Stephen Hawking is one of the greatest thinkers of all time. He's on a mission to understand the moment of creation, the instant the universe was born. 20 years ago, he wrote a book on the subject that became an international bestseller. In it, he promised that soon he would have a single theory so powerful it would explain every mystery in the cosmos. Why did the universe spring into existence, and will it ever come to an end? A theory of everything. We are getting close to answering the age-old questions. Why are we here? Where did we come from? His determination to find answers has kept him alive far longer than any doctor predicted. Stephen has tremendous determination to solve the problems of the universe, and I think that is one of the key factors that has kept him going all these years. But he lives life on borrowed time. The idea that my father had a very short lifespan was always present. I think it was there every single day. Hawking will not rest until he unlocks the secret of how the universe came to be. My goal is simple. It is a complete understanding of the universe, why it is as it is, and why it exists at all. Born in 1942, Stephen Hawking was always fascinated by the world around him. As a healthy child, he wondered what made the stars. By his teenage years, he wanted to find out where the entire universe came from. In the 1960s, scientists still hadn't answered that question. Many believed our universe had no beginning, that it was timeless and unchanging, but a new theory was gaining ground. Everything in our universe exploded from one tiny point, like a burst of fireworks. Scientists called it the Big Bang. Yet how could we suddenly go from nothing to everything in one moment of creation? At just 20 years old, Stephen Hawking began his first mission, to find out. In 1962, he had just started his PhD at Cambridge University, eager to prove himself. According to his old friend Kip Thorne, Stephen was beginning to develop a reputation, but just barely. It wasn't at all obvious that he would come to tower over the rest of us. Around this time, Hawking noticed he was becoming very clumsy. A hospital visit led to a shocking diagnosis. He had amyotrophic lateral sclerosis, ALS, a disease that wastes muscles. Soon he would be completely paralyzed. Doctors gave him just 2 years to live. Hawking was only 21. His dream of unraveling the universe's mysteries seemed to crumble. I had just been diagnosed with ALS, and I didn't know if I would live long enough to finish my doctorate. It was the darkest period of his life. According to his daughter, Lucy Hawking, he became very depressed. He was looking for a PhD topic but saw no point. Everything seemed bleak and hopeless. But then Hawking met Lucy's mother and fell in love, despite his death sentence. Getting engaged and married was the turning point that gave him hope and made him decide to carry on. Hawking set out to discover the universe's origin before time ran out. Does the universe, in fact, have a beginning or an end? And if so, what are they like? Scientists were skeptical that something could come from nothing, as the Big Bang suggested. Hawking wanted proof. His first break came in 1965, when he attended a lecture by brilliant mathematician Roger Penrose. Hawking listened closely, asking pointed, difficult questions. Penrose suggested something astonishing. There's a hole in space where huge objects can disappear. If matter can vanish into nothing, maybe it can also appear from nothing. This could help Hawking prove the Big Bang. But how can there be a hole in space? The answer lies with gravity. Einstein's general theory of relativity said gravity wasn't just a force. It actually bent space. Physicist Pedro Ferreira of Oxford University studies gravity's impact. Einstein realized gravity wasn't a force between two bodies, but something more elegant and beautiful. Einstein imagined space and time as a fabric. Planets and stars pressed on it, creating dips. Gravity was not a force, but the curvature of this fabric. Objects moved along these curves. If an object were heavy enough, it could create a deep depression, a hole in space, where things disappeared forever. Such a hole is a black hole. When a star 20 times bigger than our Sun dies, it collapses, becoming incredibly dense. It presses so hard on space-time that it creates a bottomless pit. Nothing can climb out, not even light. At the center of a black hole is a singularity, a point of infinite density. Here, space and time end. Hawking wondered, if matter disappears into nothing, then maybe the opposite could happen. The Big Bang theory said the entire universe emerged from a tiny singularity. If you run time backward, the expansion becomes a collapse. A reverse black hole becomes a Big Bang. Hawking realized that if you reverse Penrose's theorem, a collapsing black hole becomes an expanding universe. He proved the universe suddenly appeared from nothing, exploding from a singularity. The debate ended. The universe had a beginning in time. This was finally proved by Penrose and myself, using Einstein's relativity. Hawking had found the origin of time, but not a way to stop it. Now 26, his disease worsened. He could no longer walk, but his mind brimmed with questions. He knew the universe began, but not what caused it to explode into being. This would be his greatest challenge yet. Could he find the answer before his body failed? Hawking realized he needed both Einstein's relativity and the laws of quantum mechanics. Relativity worked for large objects, quantum mechanics governed atoms. At the Big Bang, the entire universe was smaller than an atom. Gravity and quantum rules clashed. Hawking needed to unify them into a theory of everything to understand creation itself. He returned to black holes, where huge mass collapses into a tiny point. Gravity and quantum mechanics must meet there. According to relativity, nothing escapes a black hole, but quantum theory said space is filled with virtual pairs of particles popping in and out of existence. Hawking imagined a pair forming near a black hole's edge. One particle falls in, the other escapes, becoming radiation. This Hawking radiation proved black holes slowly evaporate and can even vanish. Gravity and quantum mechanics worked together to make this happen. The world was stunned. By definition, black holes aren't supposed to emit anything. Hawking showed two opposite theories could work together. It was the closest anyone had come to a theory of everything, but a fatal flaw remained. After the Big Bang, gravity mysteriously weakened. Had it not, the universe would have collapsed back on itself. Why did gravity weaken just enough to allow stars, planets, and life? Hawking sought an explanation. As he typed his papers, letter by letter, his family feared he worked too hard. Then tragedy struck again. In 1985, Hawking caught pneumonia. An emergency tracheotomy saved him but cost his voice. Cut off from the world, he fell into despair. 6,000 miles away in Lancaster, California, speech software designer Walt Woltos learned of a Cambridge physics professor who needed help. Walt donated a machine that let Hawking talk again. A tiny movement of his finger let him pick words from a predictive system. With this voice, Hawking rose like a phoenix. He returned to Cambridge, determined as ever to find the final theory. But another contender emerged, string theory. Created by Michael Green and others, it suggested that all matter is made of tiny vibrating strings, one ingredient for everything. String theory needed extra dimensions of space to explain why gravity weakened. If gravity spread into hidden dimensions, it would dilute enough to allow the universe to expand rather than collapse. String theory offered the missing piece. Hawking admired it, though he remained cautious. Yet string theory still lacked proof. That might change with the Large Hadron Collider at CERN in Geneva. By recreating the conditions just after the Big Bang, scientists hoped to see evidence of extra dimensions or tiny black holes evaporating instantly, just as Hawking predicted. This could confirm his life's work, yet delays and complexity mean waiting years. Hawking, now one of the longest-living ALS patients in history, still hopes to see that day. We have grounds for cautious optimism that we may be nearing the end of the search for nature's ultimate laws. Stephen Hawking has fought the biggest mysteries in the universe and prevailed. He found the universe's birthplace and showed black holes can leak radiation. He mirrored this triumph in his battle against disease, outliving every dire prediction. The greatest thing I learned from my dad is that if you fall into a black hole, don't give up, you can get out again. He is as determined as ever to find that final equation. The ultimate theory of everything, one equation to describe all creation, still eludes him, but he will never stop trying.